on December 19th, we'll have the best opportunity to use the hundreds of telescopes on Earth and the Hubble and Webb space telescopes to get our best data on it.
We told you about 3I Atlas when it first appeared in our solar system, the third confirmed interstellar object ever detected. Scientists calculated its trajectory based on the data available. Then the data started changing. NASA has now revised Atlas's path multiple times. The latest model required increasing its acceleration by a factor of 6 just to match what observers are seeing. So what's causing the shift? And is Atlas drifting closer to Earth than originally calculated? The basic facts. 3I Atlas is not a normal space rock. It is moving on an interstellar hyperbolic path, which means it came from outside our solar system and will keep going forever. It will not loop back around the Sun like usual comets. Only 2 other objects like this have ever been seen before, so Atlas is very rare and very important. Atlas passed its closest point to the Sun on October the 29th, 2024. After a comet passes the Sun, it normally cools down and becomes quiet. The heat fades, the ice stops melting, and the bright tail slowly disappears. But Atlas is not doing that. Even though it is moving away from the Sun, it is still sending out gas and dust. This has surprised many scientists, because a fading comet should not be active anymore. Right now, Atlas is about 300 million kilometers from Earth. This is roughly 2 times the distance between Earth and the Sun. At that huge distance, a comet should be very faint and very hard to see, but Atlas is still showing signs of activity. It is not bright, but it is more active than anyone expected at this stage. Scientists are trying to understand why. Some think the object may hold unusual ices that start to warm and escape even far from the Sun. Others think Atlas formed in a very different kind of star system, so its materials might behave in ways we have never seen before. Because it came from another part of the galaxy, it may carry chemicals that do not exist in our solar system. Whatever the reason, the main point is simple. Atlas is still active when it should be quiet. This strange behavior is forcing scientists to rethink what interstellar objects are made of and how they act when they enter our solar system. But staying active is just the beginning of what makes Atlas so strange. The real mystery starts with what's pointing the wrong way. The anti-tail problem. 3I Atlas has 2 tails, and that is the start of the mystery. The first tail is normal. It stretches away from the Sun, just like every other comet tail. The second tail, however, points forward, toward the Sun. This strange forward tail is called an anti-tail. The anti-tail of Atlas is huge. It reaches more than 1 million kilometers in length and aims straight at the Sun. Normally, anti-tails on other comets are only tricks caused by the viewing angle. But in this case, scientists have checked the data many times. This is not an illusion. Atlas truly has a long, real, forward-pointing tail. The real problem is the physics behind it. The solar wind blows outward from the Sun at about 400 kilometers per second. A comet's own gas moves at only about 400 meters per second, which is much, much slower. For Atlas to send material forward against the solar wind, the gas would have to move about 1,000 times faster than any known comet material can move. That is impossible with the laws of physics we understand. Also, the strong push of the solar wind should destroy any forward-moving jet almost immediately. The pressure from the Sun should wipe it out within only a few thousand kilometers, not let it stretch for more than 1 million kilometers. Yet the anti-tail stays in place. There is another strange part. For Atlas to create such a strong and constant jet, it would need to lose around 200 metric tons of material every second. Over October and November, the total lost mass would be several billion tons, close to 10% of its whole estimated mass. With that much material gone, the object should be broken apart or heavily damaged. But Atlas is still in one piece, and no major fractures are seen. This is why the anti-tail of Atlas is one of the biggest mysteries scientists are trying to explain. A backward tail that shouldn't exist is puzzling enough, but the way Atlas moves makes even less sense. Movement anomalies. Before 3I, Atlas reached its closest point to the Sun. It behaved in a very strange way. It showed zero non-gravitational acceleration, which means it moved exactly like a solid rock. There were no signs of gas or dust pushing it along. Almost all comets release gas as they warm up near the sun. This gas acts like tiny rocket thrusts, slightly changing the comet's path. But Atlas did not show any of these signs. It followed a clean, perfect trajectory, shaped only by gravity. This is highly unusual for a comet that should have been heating up and becoming active. Everything changed after October 29th. Once Atlas passed perihelion, scientists detected a small but real acceleration that could not be explained by gravity alone. This sudden push suggested the object was ejecting gas or dust, even though it had shown no activity before. The amount of force needed to produce this acceleration is enormous. To match the observed numbers, Atlas would have to throw out more than 10% of its total mass in a short time. Combined with the mass it already lost at perihelion, the total loss would reach about 20% of its entire body. A small icy object cannot survive losing this much mass without breaking apart. Most comets crack, split, or disintegrate after losing even a few percent of their mass quickly. Yet, Atlas remained fully intact, showing no major fractures. Its behavior, motion like a solid rock, then sudden powerful thrust, all while staying intact, does not match any known comet physics. This makes the movement of 3I Atlas one of the greatest mysteries in recent astronomy. First, it acted like a rock, then suddenly it didn't. And the strangeness doesn't stop there. The jet itself behaves like nothing we've ever seen. Jet behavior problems. One of the most puzzling features of 3I Atlas is its anti-tail. This forward-pointing jet stretches for more than 1 million kilometers and is clean, straight, and stable. It does not bend, twist, or break apart like normal comet jets. Typical comet jets are chaotic. They change shape as the comet rotates or as gas and dust flow into space. They often form spirals, cones, or fuzzy clouds. But the anti-tail of Atlas remains perfectly straight for long periods. It behaves as if it is tightly controlled, rather than created by random natural vents. This is very difficult to explain with normal physics. Atlas rotates about once every 16 hours. On a normal comet, spinning with vents on its surface would make the jets move in sweeping spirals or cones. The rotation would create clear repeating patterns as the object turns. We see this in almost every comet, but Atlas shows none of these patterns. The forward jet looks like a solid, uninterrupted column. It does not pulse, bend, or curve with the spin. The jet behaves as if the rotation does not affect it at all. Another unusual clue comes from its brightness. The light from Atlas changes by 10 to 20%, and these variations match the 16-hour rotation exactly. Normally, the coma, the cloud of gas and dust around the nucleus, does not rotate, so the brightness should stay steady. Yet Atlas's light rises and falls in perfect sync with its spin, showing that something near the core is changing in a very organized way. Natural comets do not behave like this, making Atlas extremely mysterious. A perfectly straight jet that ignores rotation is bizarre, but where Atlas is heading next makes scientists even more curious. The Jupiter trajectory. 3I Atlas is moving toward the region of space where Jupiter's gravity becomes stronger than the pull of the Sun. This area is called the Hill radius. It acts like an invisible bubble around Jupiter. Inside this bubble, Jupiter's gravity controls the motion of objects. Anything that enters the Hill radius can be captured or guided into a stable orbit. This idea matters because the Hill radius is often used in planned space missions. Sending a probe through this region makes it easier to place it into a safe and long-lasting orbit around Jupiter. The path of Atlas is notable because it heads toward this important region with precise alignment, which makes the movement especially interesting to many researchers. The first path estimated by the Jet Propulsion Laboratory showed Atlas passing inside Jupiter's Hill radius in March 2026. Avi Loeb, a well-known scientist, wrote a report to NASA pointing out the close match between the path of Atlas and the boundary of Jupiter's influence. A few days later, JPL released a new model with strong changes. In the updated path, Atlas no longer entered the Hill radius. Instead, it passed just outside of it. To match this new path, the model required large changes in the numbers. The non-gravitational acceleration had to be increased by a factor of 4, and then later by a factor of 6. These numbers are very high for an object that showed almost no such forces before it passed the Sun. These rapid adjustments and large shifts created a new picture of the object's movement. The updated models placed Atlas outside the Hill radius, but still close enough to feel Jupiter's strong pull. The movement remains unusual, and the timing of the changes remains a major point in the study of 3I Atlas. The path keeps changing in NASA's models, and nobody's quite sure why. Some researchers think the answer might not be natural at all. Alternative explanation. One idea scientists are exploring is that 3I Atlas might have artificial propulsion. In other words, the forward jet and strange movement could be powered by technology instead of natural comet activity. If we think of simple chemical thrusters, they can produce exhaust at about 4.5 kilometers per second. Even more efficient are ion engines, which can be 10 to 1,000 times more efficient than chemical thrusters. These speeds and efficiencies are enough to make the strange behavior of Atlas possible. Using these numbers, the math starts to work. The object's mass budget can fit with the required acceleration. The unexpected acceleration itself can be explained by continuous propulsion. The strong structural integrity of Atlas also makes sense, because an engineered object could withstand high stress better than a fragile icy comet. Finally, the perfectly collimated jets, including the forward anti-tail, could be controlled by design instead of happening naturally. This explanation does not break physics. Instead, it offers a clear way to explain all the anomalies in Atlas's movement, tail, and mass loss. Despite these findings, the idea of artificial propulsion has faced resistance. Multiple researchers tried to publish papers in peer-reviewed journals exploring this possibility. All of the major journals rejected the papers outright. The unusual part is that many were not even sent for peer review. The reason for rejection appears to be social rather than scientific. The conclusions make people uncomfortable, not because the research is wrong or the numbers are impossible. Ideas that suggest technology or intelligence outside Earth can be applied to an interstellar object are often considered too controversial. Even so, the artificial propulsion explanation continues to be studied. It remains one of the few models that can account for all of Atlas's strange features in a single framework. The math works, but the idea is unsettling. Meanwhile, amateur astronomers confirm that something truly strange is happening. Amateur astronomer observations. Amateur astronomers around the world have been closely watching 3I Atlas with backyard telescopes. Even though their equipment is smaller than professional observatories, many have captured detailed images of the object. Some photos show sharp features on the surface and active jets of gas and dust streaming from the nucleus. These independent observers have also tracked brightness variations that match the rotation of Atlas. The light from the object rises and falls in ways that are very similar to what professional telescopes report. This shows that the unusual patterns are not caused by errors in large instruments or by atmospheric interference. The images and data collected by amateur astronomers are often easier to access and follow over long periods of time. They have been able to spot changes in the anti-tail and other jets that are difficult to monitor with professional telescopes, which are usually booked for short observing sessions. Many of the patterns observed do not match the official explanations provided by standard comet models. For example, the sharp, straight anti-tail, the timing of brightness changes, and the continuous activity all appear in amateur data. These independent observations give additional evidence that something unusual is happening. By combining these reports, scientists can verify anomalies seen by professional observatories. Amateur astronomers have effectively created a global network of independent observers. Their contributions help confirm that Atlas is not behaving like a normal comet, and that the unusual features are real and persistent, not temporary artifacts or illusions. Amateur observations continue to play a critical role in understanding the strange behavior of 3I Atlas. Backyard telescopes from around the world all show the same weird patterns. Soon, we'll get our best look yet. Upcoming observations. In 18 days from now, 3I Atlas will make its closest approach to Earth since the Hubble images taken in July. This is a rare opportunity for astronomers, both professional and amateur, to observe the object in detail. Major space telescopes, including Hubble and James Webb, are scheduled to watch Atlas during this time. At this distance, the object should be fading as it moves away from the Sun. Most comets become less active after perihelion, and the same is expected here. However, Atlas has defied normal behavior in the past. Observations in December will test whether the anomalous activity continues. Any jets, anti-tail features, or brightness changes will be closely monitored to see if they match previous patterns or fade as expected. The next major event is the Jupiter flyby on March 16, 2026. This will be the definitive test of Atlas's trajectory and behavior. Multiple spacecraft, including Juno, JUICE, and Psyche, will track the object as it passes near Jupiter. Amateur astronomers will also continue to measure its path from Earth. The flyby will reveal if NASA's revised forecast is accurate. Scientists will compare the actual trajectory with the predicted path. Observing how Atlas interacts with Jupiter's gravity will provide critical information about its mass, structure, and the forces acting on it. These upcoming observations are highly anticipated because they will help answer many of the remaining questions about Atlas. For the first time, astronomers will be able to see whether the unusual activity, jets, and movement continue under extreme conditions, providing key insights into this mysterious interstellar visitor. 3I Atlas continues to defy expectations, from its million-kilometer anti-tail to sudden acceleration. Don't miss the latest updates. Follow professional and amateur observations, track its path, and stay informed as scientists study this mysterious interstellar visitor. Subscribe and keep watching as Atlas approaches Earth and flies by Jupiter in March 2026.